By now you know how to factorize a formula when all of its terms have a common factor. But there are situations where you can factorize even though the terms in your formula don't have a common factor. And in this video we will look into that, and again we can understand it as the reverse of what you do when you simplify a formula. This formula is a product, a multiplication. We multiply x plus 4 by x plus 3. And when we simplify, we want to get rid of the brackets, and we do that by multiplying every term inside of these brackets by every term inside of these. And then we add the results. So we get x squared plus 3x plus 4x plus 12. And we can simplify because 3x plus 4x is 7x. And it's useful to note what happened to this 4 and 3. In this term, we added 3x and 4x, and we got 7x. So we took the sum of 3 and 4 and got 7. And in this term, we multiplied 3 and 4 and got 12. Similarly, for this formula, we get x squared minus 2x plus 5x minus 10. And we simplify minus 2x plus 5x is 3x. And again, note that this plus 3 is the result of adding minus 2 and plus 5. And this minus 10 is the result of multiplying this 5 and this minus 2. And this is going to be important because, like in the previous video, sometimes we want to go the other way. Sometimes we start with a sum of 3 terms like this or like this, and we want to go back to this multiplication of 2 pairs of brackets. So we get something like x squared plus 7x plus 12, and we want to make a product out of it. Now these terms don't have any factor in common. This one doesn't have any numbers in it, and this one doesn't have any letters, so they don't have anything in common. But it may still be that we can write this as a product of 2 pairs of brackets. X plus some number times x plus some other number. And the puzzle, and this often does feel a bit like a puzzle, the puzzle is to figure out which numbers need to go here on the place of these question marks. And we always get 2 clues in this puzzle. The first clue is that when we multiply these 2 numbers, we get 12. So we know that the product of our numbers has got to be 12. And the other clue is that we multiply both of these numbers by x at some point. And then we add up the results to get 7x. So the sum of these 2 numbers has got to be 7. So we are looking for 2 numbers, in short. We are looking for 2 numbers whose product is 12 and whose sum is 7. How do we find these 2 numbers? Well, experience is the best guide here, but we can do this step by step. And then the first step is to list all the numbers whose product is 12. And then for each pair of numbers, we can check what their sum is. So how can we get to 12? Well, very simply, 12 is 1 times 12. So 1 times 12, 1 and 12 may be an option. 2 and 6 also gets us 12. And 3 and 4 gets us 12. And for completeness sake, we could have negative numbers. So we could have minus 1 times minus 12, or minus 2 times minus 6, or minus 3 times minus 4. These are all the options with whole numbers. Now, if we take these 2 numbers, 1 and 12, what is their sum going to be? Well, their sum is going to be 13. And we do want a sum of 7. So this option is not going to work. 1 and 12 is not going to work. 2 and 6, for the same reason, is also not going to work, because the sum of 2 and 6 is 8. And that's also not 7. But 3 and 4 is going to work, because 3 plus 4 is indeed 7. So we can stop. There's always just one solution here. So we have found our 2 numbers. The product of 3 and 4 is 12, and the sum of 3 and 4 is 7. And that means we can write this formula as a product of these two factors, x plus 3 times x plus 4. If we simplify this, we get this again. Okay, so let's look at a few more examples, especially to see some tricks about how you can find those two numbers that you're looking for, because that's usually the most difficult part. So we are given this formula and we need to write it as a product. So that means we're going to write it as the product of x plus something times x plus something else. And our clues are that once we multiply these two numbers, the result is going to be 36. So the product of the two numbers we're looking for is 36. And also when we do x times this and this times x, the result is 13x. So that means that when we add these two numbers, the result is going to be 13. So the sum is 13. Now, we always start from the product, so we're going to look at numbers whose product is 36. It can be two negative or two positive numbers, but I see that the sum of my numbers is positive, so probably only positive numbers is going to work in this case. So how can I get to 36? By a multiplication. Well, 1 times 36 works, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. So I'm going to check each of these pairs and see what the corresponding sum is. If I pick 1 and 36, then the sum would be 37, and that doesn't work because I want my sum to be 13. So 2 and 18 doesn't work either, 3 and 12 doesn't work, 4 and 9 does work because 4 plus 9 is 13. So 4 and 9 is a pair of numbers that works because 4 times 9 is 36 and 4 plus 9 is 13. So I can rewrite this as x plus 4 times x plus 9. Here we have x squared minus 10x plus 21. So my clues are that when I'm going to rewrite this as x plus something times x plus something, then the product of these two numbers is going to be 21, and the sum of these two numbers is going to be minus 10. So I have two numbers and their sum is minus 10. So a product of two numbers, how can I get to 21? Well, 1 times 21 could work, 3 times 7 could work, and I could have negative options. Minus 1 times minus 21 also gives me 21, and minus 3 times minus 7 also gives me 21. And actually, because the sum of my numbers is going to be negative, I know that these are the only viable options. Nevertheless, let's go through them all. 1 plus 21 is 22. Well, that's not equal to minus 10, obviously. 3 plus 7 is 10, so that's not equal to minus 10, and we need minus 10. Minus 1 plus minus 21, that's minus 1 minus 21, is minus 22. Doesn't work either. But minus 3 plus minus 7, that's minus 3 minus 7 is minus 10, and that does work. So the pair of numbers I am going to use is minus 3 and minus 7. So that means that I get x plus minus 3 and x plus minus 7. But of course, I'm going to simplify this. I'm just going to write x minus 3 times x minus 7. And that is the result of factorizing this formula. Two more examples. How do we write this as a product? And let's try to start doing this a bit quicker. So we see that we need two numbers. Their product is minus 6 and their sum is minus 5. Well, because the product is negative, I know that I need to have a pair of one positive and one negative number. So I have a lot of options. Could be minus 1 times 6, minus 2 times 3, 1 times minus 6, or 2 times minus 3. Okay, so let's check the sums. Minus 1 plus 6 is 5, but we need minus 5, so that doesn't work. Minus 2 plus 3 is 1, no. 1 minus 6 is minus 5, and that's enough, so we stop here. So the pair of numbers is 1 and minus 6, so we get x plus 1, this was positive 1, and x minus 6, and that's how we factorize this. And finally, and once we get better at this, we can try to do this without a table like this and try to just do this in our heads. We are going to factorize this. We are going to look for two numbers whose product is 100 and whose sum is minus 20. And using the tricks we've seen so far, those two numbers I'm looking for are either both positive or both negative, because their product is positive. But I see that their sum is negative, so that means that at least one of them is negative. So I know now that my only options are two negative numbers. Two negative numbers that multiply to 100, well, could be something like minus 1 times minus 100, but that definitely not going to give me the right sum. So this is probably something with 10 and 10. So minus 10 and minus 10, that actually works. Minus 10 times minus 10 is 100, and minus 10 minus 10 is minus 20. So that works, and I can immediately write down the factorization. This factorizes to x minus 10 times x minus 10. So sometimes these two numbers will be the same. Now let's practice with this, and it's good to have some kind of step-by-step plan for doing this in your system. So when you're asked to factorize something, the first thing you need to think about is what are the two numbers I'm looking for? What are my clues? So the clues are that I'm going to look for two numbers with sum 5 and product 6. And then I'm going to look for those numbers using a table or maybe doing that in my head. So I'm going to look for those two numbers. Which two numbers have sum 5 and product 6? Well, that's going to be 2 and 3, because 2 plus 3 is 5 and 2 times 3 is 6. So my numbers are 2 and 3. And that means that my solution is going to be x plus 2 times x plus 3. Now, pause the video and see if you can do that for all of these formulas. All right, so in this formula, we are going to look for two numbers with the sum 3 and product 2. And those numbers are going to be 2 and 1. 2 times 1 is 2, and 2 plus 1 is 3. So the solution is x plus 1 times x plus 2, or x plus 2 times x plus 1. The order here doesn't matter. Here the sum is going to be 11 and the product is 24. And two numbers with sum 11 and product 24 are 3 and 8. So the result is x plus 3 times x plus 8. Here, be careful, the sum is going to be 8 and the product is 15, even though this is in a weird order. So we're going to look for two numbers with sum 8 and product 15, and those two numbers are going to be 5 and 3. So this is our solution. Here we're going to look for two numbers with sum minus 4 and product 4. So that's going to be two negative numbers, and what works is minus 2 and minus 2, because minus 2 is minus 4, and minus 2 times minus 2 is 4. So these are my two numbers. So this is the solution, x minus 2 times x minus 2. Here the sum of my two numbers is going to be, well, there isn't a number visible here, but that means that secretly we have a 1 here. X is just 1x. So the sum is 1 and the product is minus 6. The product is negative, so that means I have a negative and a positive number. The sum is still positive, so the positive number is a bit bigger. So what works is minus 2 and 3. So we get x minus 2 times x plus 3. X squared minus 3x plus 2. So now we have two numbers with sum minus 3 and product 2. So these are going to be two negative numbers because their product is positive and their sum is negative. We've already seen a similar version here, but now the numbers are negative, so we get minus 2 and minus 1, or minus 1 and minus 2. So this is the solution, x minus 1 times x minus 2. Some bigger numbers here. Sum is 100 and the product is 2500. Well, when you look at this, you will eventually, hopefully, figure out that 50 and 50 are going to work. because 50 times 50 is 2500 and 50 plus 50 is 100. But this will maybe take some experience before you're comfortable with these larger numbers, which is fine. So the numbers are going to be 50 and 50. So the factorization is x plus 50 times x plus 50. X squared minus 16. So here the separate number is minus 16, and that's always our product, right? So the product of my two numbers is going to be minus 16. And the sum, in this case, the sum is actually going to be 0, because we don't have any term at all with an x in it. So when I added those two numbers, when simplifying in the end, I got 0 as my sum. So I'm going to look for two numbers that multiplied are minus 16, but their sum is 0. So that's a positive and a negative number, and they have to be equally big except for the sign, because then their sum is 0. So what works is the square root of 16, which is 4, and then negative 4. So minus 4 and 4, and then the result is x minus 4 times x plus 4. So now you know what you need to know about factorizing formulas, and it's about time that we start applying this to solving quadratic equations, and we're going to do this by means of a rule that we will see in the next video.